He moved to China and started working at Zhongshan University in Guangzhou as the Dean of the School of Information Management. In 2019, Professor Nunes founded the first laboratory in China dedicated to VR in digital humanities research, named VR Plus Culture. Very recently, he joined XJTLU Entrepreneur College, Taicang. Professor Nunes' research interests focus on information systems, knowledge management, and information management. He has published more than 200 refereed articles and in both academic journals and conferences. And Professor Nunes has also led several EU, UK, and Chinese-funded projects. Today, Professor Nunes will present on socio-technical innovations through design science research. He will talk for about 50 to 60 minutes, and then we will open the floor for questions and discussions. Professor Nunes.
Thank you very much for a very kind introduction. I'm very honored to be here today. A public lecture is an honor, but it's also an academic duty, and I'm very happy to be able to actually do so. What I'm going to talk today about is research, but research related to information systems and research related to the principles of research that maybe are not serving as well. So I would like, first of all, to start by presenting myself and presenting my journey, which also represents sort of my academic journey. So if you look at here, I come from this little country, the most western country in Europe. It's called Portugal. In Chinese, it's Portugal. I then moved to Sheffield. But when I moved, I made a change in careers. Until then, for 9 years, I was a programmer. My first degree is applied maths, and I became a programmer. And then I decided, this is not for me. Programming is too boring. So I moved to information management. And in my move to information management, I started dealing with a different type of issue. I started dealing not just with the technology, but what we can do with the technology to serve information needs, information behaviors, etc. And then stayed 23 years in Sheffield. Sheffield is a good university, Russell Group and all that. I did stay there for 23 years, maybe too long. Maybe I should have moved earlier. I then moved to China. I moved to China in 2 steps, actually. First, I moved to Renmin University in Beijing. And Renmin University is a social science university. They are not a comprehensive university like we are used to. And in that sense, they have a very interesting culture that identifies themselves around social issues rather than technological issues. It was a pleasure working with them. And it was a pleasure to learn from them. And then, finally, I moved to Xi'an. And now I made a little step upwards in China, and I'm here in XJTLU. Now, that journey, that was also a journey that accompanied my development as an academic and represented some changes in my thinking and changes in my research approaches, is the basis for this talk that I'm giving today. Now, what I would like to talk today is basically about information technology, information systems, research in information systems, design science research as an approach to do information systems research, and then finally, a little bit about social-technical innovation. Now, many of you maybe never heard of this word, social-technical innovation. What you heard here all the time is technology, technology, technology. What I'm going to try and prove to you today is that technology by itself is not enough. It's just not enough. We need to produce technology that is useful. We need to produce technology that is used. We need to produce the technology that meets the needs of the social environments where we actually work. Otherwise, technology by itself will not succeed. And that's what I hope I will manage to do today. Now, I would like to start actually talking about digital transformation. Now, digital transformation is something that you hear virtually every day, not just in China, virtually every day, everywhere. Now, digital transformation has many types of connotations, but it has connotations with AI, with robotics, cloud computing, all these technologies that we hear on a daily basis on the news outlets, on the Weibo discussions, on the national priorities. But what are these technologies? Why are they important? Well, they're important because they are information technologies, meaning they are technologies that help us process information. In that sense, then, it's the information technology and the information in particular that are important in terms of the digital transformation. And this is important to understand what the digital transformation then means. It just means that we're replacing some technology by another technology. We're replacing a technology that we now call digital with a technology that before was not digital. And then, therefore, we're creating a transformation. Now, why do we do this? We do this because of efficiency, performance, greater business agility, and ultimately unlocking value through that change. Now, what is information technology? I think sometimes it's important that we actually reflect a little bit about what we're actually talking about. Information technology. Information technology is just technology that helps us process data into information. It's technology that helps us share information, disseminate information. It's technology that actually is important in terms of our competition with other groups. It's important with our competition with other individuals. The more information we have, the better we are. Information technology, therefore, usually refers to any equipment or interconnected system or subsystem that is used in the acquisition, storage, manipulation, management, movement, control, display, etc. of information. Now, what I would like to ask you is, when do you think information technology appeared? So, when do you think this concept of information technology or this type of technology appeared? The answer that I usually get is the 1960s or the 1970s. Well, I'll give you an example. These are Paleolithic drawings on a wall done some 10,000 years ago by a culture and a civilization that existed at that time. What did they represent? And this is the curious aspect of it. What did they represent? The animals they hunt. How do they hunt the animals? What tools do they use to hunt the animals? Hunt in groups, not individually. You hunt individually, you die. Careful with the animal that you hunt. You hunt a bison, you die. These ones are dangerous. Be careful. Lions. These ones are dangerous. Be careful. If they are all together sleeping, no problem. If they are by themselves, be very careful. This is what we are. This is our group. If your hand is here, you're in our group. If your hand is not here, you're not from our group. ID card. ID card. Right? So, information technology has been with us for a long, long period of time. It's not new. There are several examples of information technology that we could give. The most common is the book, which is an extraordinarily good information technology. Books exist for 600, 700 years. To be honest, books in the format that we read exist for 700 years. Books in general may exist for 2,000, 3,000, 4,000 years ago. So in that sense, information technology is not new at all. So what I would like to ask is, were there periods in time in history where we actually had transformations? Were there periods of time in history where we had information technology transformation, not digital information, but information technology transformation? And the obvious answer is yes. Writing, some 5,500 years ago, it permeated into a civilization in different areas. It was more or less invented separately, therefore there were many different systems. There were much opposition to writing. The most important, or one of the most important philosophers of the ancient Greek, Socrates, was against writing. He actually died protesting against writing. He did not like writing. Writing would kill the capacity of argumentation, because as soon as you put your arguments in writing, you do not need to express them. Why do you know about Socrates? Because Plato, his student, wrote about him. We don't know anything about Socrates' teacher because Socrates never wrote about his teacher, right? So it's very curious how revolutions in IT then had an impact in the entire civilization. Writing is important because at the moment you start writing, you don't need to go to somebody to know the information. That information can come to you in several forms. That happened some 5,000 years ago. Then paper, Chinese invention, in the form of rice paper. Exported to Europe, we started using wood. Important revolution, because then we could copy several books by hand. But in copying several books and then creating books, we could disseminate information. And then we got the printing press. Now, the printing press is a very curious thing, because the printing press is another Chinese invention. But it didn't have a big impact in China. In China, it did not have a big impact. Actually, it had a very low impact. Because in order to do the press, you need 3,500 characters. Therefore, you need to produce 3,500 characters several times to produce a plate, to produce a book. In Europe, we have 23 letters. We can produce masses of letters and then change the plate very easy. So Europe went from being one of the most ignorant and the lowest civilized continents in the world. At that time, Chinese culture, Indian culture were much superior. Even potentially Muslim culture was, at that time, the Arab culture in the southern Mediterranean was much superior. And then all of a sudden, Europe, from one decade to the other, became completely different. We call it the revolution of the light, because it sort of illuminated the continent. We started producing books in massive quantities. All of a sudden, information could be disseminated enormously fast. People start reading. Before that, nobody read. And all of a sudden, European culture went from virtually nothing to extraordinary heights, of which we still, me, Portuguese, Angelos, Greek, from which we are still taking benefits now, today. But that was 500 years ago. Then, some 75 years ago, is disputed, there is some controversy as when the first computer appeared. Some says ENIAC, the others say is the computers used in the First World War. It doesn't really matter. It's around 75 years ago. It completely changed the way we process information. So it was the first time that we had the capacity to all of a sudden process a lot of data. And it did have some implications, but not major. Not major. What had a major implication was this other transformation, the internet. Because here, it changed the way we access information. And this is so interesting that when I was doing my PhD in 1993, 1994, 1995, in 1993, there was no internet, only Unix machines with a very rudimentary kind of browser. In 1994, we had PC-based browsers. All of a sudden, it was a different world. My supervisor calls me and says, forget what you've done before. You need to start everything again. We have the internet. So this is a true revolution. And of course, then, and of course, then there was the mobile technologies. Mobile technologies was a big revolution. Mobile technologies allows you, with your little smartphone, to do everything that you used to do in 10 different technologies. TV, you watch your movies. Music, you listen to your music. Internet, you don't need a computer. So all of a sudden, there was an integration of technologies into this small machine that actually you carry with you. Big transformation. And then the smart technologies, the smart cities, the smart health, some 7 years ago. And then some 7 months ago, we get these generative pre-trained chatbots, right? Now, what is interesting about this sequence? From this one to this one was about 2,500 years. From this one to this one was about 2,000 years. From this one to this one is about 425 years. And then all of a sudden, it's happening at a pace that we cannot cope anymore. So it's this speed of the evolution of information technology that creates the problems that we have today. It creates a almost incapacity to keep on producing theories about a reality that is changing every day. There is a huge difficulty in doing research on environments that are in continuous change. And most of the time, we're doing research in the past about theories, about the use of a technology that maybe is already outdated when after 3 years of doing a PhD, you finished. And it's very curious how we need to change that. So that is why I wanted to talk about information technology before talking about information systems. Now, information systems are systems that facilitate the flow of information and provide a technological solution for this flow of information. So it's an easy concept. It's not the technology itself, it's the systems that use the technology. So a small difference. And when we talk about information systems, we're talking about information systems in an environment that is changing so fast that almost makes it impossible for us to keep up. Now, in terms of an academic discipline, and I apologize, but I need to talk about academic discipline because, after all, I'm an academic, I would like to explain a little bit about what information systems is. Information systems is a discipline that is surrounded, accompanied by, together with computer science and management science. And it integrates the two. In that sense, it's a discipline that is interdisciplinary, a word that we use a lot, a word that sometimes is not easy to understand. It has to do with sharing concepts, methodologies, procedures, terminologies. And we do share those with computer science, and we do share those with management science. So information systems does not exist separately. It exists together with these disciplines. But being together with is not enough, right? So we need to understand what IS is in reality. So the easy way to explain this is electronic engineering produces this, the hardware, right? Computer science produces the software that actually makes the hardware work. We try to understand how the combination of I'm still getting used to this clicker. The combinations of hardware and software actually resolve problems of information need, information use, information behaviors, organization of information, and management of information from a technological perspective, meaning from the use of these two. We are then sandwiched by management that then has other worries. Management studies are worried about decision making, worried about business processes, are worrying about business processes management and business process optimization, interested in how to lead in organizational behaviors that are very specific from organizations, and organizational cultures that are very specific from organizations. And in that sense, it's a discipline that is sandwiched between the more technical aspects and the more management aspects. So here we are all about collection, classification, organization, processing, storage, retrieval, usage, protection, and dissemination of information. And organizations all over the world need to engage with these problems. Organizations all over the world need to collect information, both from the inside of the organization, but also from the outside. Competitor information, customer information, all kinds of information about regulations and policies. They need to have that, otherwise they will not succeed. And of course, they also collect information from the overall environment. If they don't, then disaster happens. When I came to Guangzhou, so this was 2017, 2018, there was a company that made a company that produces little cars. Exact models of cars, but as little models. And they produced them wonderfully painted, and they got a huge contract with a massive, absolutely massive toy company in the world. And then they started about innovation, and they started painting the cars with a better paint that was more bright and had lead. And then a week after that, they lost the contract. Yes? Why? They didn't look at policy actions, and they did not look at cultural and ethical regulations outside. What do kids do with cars? You put lead on the paint of the car, you poison the kid. It's forbidden to put lead in paint for children toys. They lost the contract. They had the best cars. They chose the best technological solution, bright, and they lost the business because they did not have the right information to actually pursue their ideas. So in that sense, collection, classification, organization, processing of information is fundamental. But then you need to store it, you need to put them in the database somehow, and you need to take it out of the database when you need it. Retrieval. And then you use it, and these days you really need to protect it, right? So you need a good level of information security when you're actually working. So all this is what we do in information systems. Now, it's all about people with information needs, with using information, seeking information, creating information and knowledge, because people are constantly creating information and knowledge. But it's also about the information environments themselves, the channels in which we actually use these information resources, and the capacity to actually identify the needs, storing, retrieving, sharing, disseminating information, and also the wider context. Organizations are open systems. Organizations are always between different elements outside their borders, outside the boundaries of the organization. They are always under pressure by customers, by competitors, by policies. So they are constantly in need of actually look at the wider context. Now, what does information systems do that computer science does not? Computer science focuses on the technical system. We focus on the technical system together with the social system where the technical system is going to work. And the environment where it works. And the organizational requirements. So in that sense, it's a different approach. It's the approach between using a technology and developing a technology. I think this approach has been negative for information systems. This is a traditional approach. It has been a little bit negative for information systems, because then we're always behind. We're always using with the technology from yesterday. We're always doing theories from the technology from yesterday. We're always looking at resolving requirements with technologies from yesterday. And in that sense, I think, has been, although this is the traditional approach in information systems, I think, in my opinion, we need to evolve from that. We need to go to a more proactive kind of approach. Now, how do we do research in information systems? Well, I want to talk about research. Everybody talks about research. But what is research? It's a word that is much used, almost as much as AI and robotics. But we need to be very careful with it, because research has a particular meaning and has a particular purpose. It has a purpose to gain knowledge and to gain understanding. So, research is original investigation undertaken in order to gain knowledge and understanding. And another definition that is very similar, creative work undertaken on a systematic basis in order to increase the stock of knowledge, including knowledge of humanity, culture, and society, so not just scientific knowledge, and to use this stock of knowledge to devise new applications, not to replicate what already exists, but to create new applications for that knowledge. Now, you read these definitions, and they seem very clear, except they are not very clear at all. They're absolutely not clear at all, because, one, what's understanding? What does that mean? What's knowledge? And exactly what does that mean? And then systematic, what does that mean? And again, investigation. So we come up with these definitions, and then I think we create more harm than good, because we are leaving so many aspects outside that actually makes it very difficult for people, even for us, to understand what you're doing. Very often you may ask yourselves, I'm doing research, but what does that mean? What is the objective of doing research? What is this aspect of understanding and knowledge, right? So, in order to understand this, we need to go to the basics of the philosophic foundations of our work as academics. We need to understand very well what the environment, what is the philosophical support for our activity. That means we need to do two very important things. One, understand how we perceive reality around us. What is the reality around us? How do we perceive it? And then another question, completely different, is how do we learn about that reality? Which are two different questions that, if we don't answer, we take implicitly. And that's what a big percentage of people in sciences do. They take for granted a type of ontological and epistemological assumptions that they never even question, because they take it implicitly rather than actually make a choice. So why do they need to make a choice? One, ontology. It's the study of the reality in which we are agents. Is try to understand what exists around us, what composes that existence, how do we interact with these components, and how do we define and categorize the entities that we interact with. This is fundamentally important because it presupposes a number of assumptions that if we never make clear, we may take for granted and run very big risks. Now, there are usually there is a dichotomy that is obviously the one that everybody uses. This is a simplistic. example, we could complicate it. But basically, there are two types of ontological approaches: objectivism and subjectivism. In objectivism, reality is external to us, and our duty as a scientist is to understand that reality that is outside our control, and it's external to our actions. Now, this is typically a natural science approach. We live in natural science environments. We actually are agents in changing those natural environments, but the laws for the natural environment are always there. So I would like to do an experiment to you to prove the basis for this epistemology, ontology. What am I trying to prove? Gravity. Okay, so if I do this experiment here, in the UK, in my country of Portugal, or somewhere in Brazil, I'll get always the same result. Right? If I get always the same result, then this is a natural law. A natural law that I can model, and that I can then create universal laws about it. Interesting. What about systems that are not natural? What about social systems? Is it true that everything that is true here in China is the same as in the United States or the same in Europe? Absolutely not. So if we then are going to do research in social environments, we cannot, absolutely not, an objectivist approach. Because if you take an objectivist approach, we are going to create problems. No matter how many statistics we use, no matter how many mathematical models we use, all what we can do is describe what happens here without knowing if it's going to be valid over there. There are no universal laws. If there are no universal laws, then the reality is what we understand is around us, is socially constructed in the group where we are. There may be many realities about the same issue. And those many realities may need very many different systems, very many different approaches, very many different requirements. And science aims at understanding these realities rather than the universalization of theory. Interesting, very important. And if you are actually looking at doing research, we need to choose one, because they are not compatible. Now, I can give you an example on why this is important. When I came for the first time to China in 2004, I think, I went to Wuhan. I was not married with my wife then, yet. I went there because I became a visiting professor at the Huazhong University in Wuhan, the Science and Technology University in Wuhan. And I spent my sabbatical there, spent 6 months there. It was a very interesting experience. First time I came out, it was a different China. And shops used to have red banners in front of the door. And almost all shops had red banners in front of the door. So you would go walk on the street, and there was red everywhere. Question, what is the meaning of the color red in Europe? Danger, right? So I walk in the street, and my senses tell me this is dangerous, right? So what I see, it's important that you understand, what I see that is around me is the color red. I do not know that gold upon red is an auspicious combination of colors. I don't know that young ladies married on red and yellow. I don't know that that is the color to try and attract good luck, and it's a very good color in China, rather than a very dangerous color in Europe. So if we're doing research in social systems, we need to understand that systems, cultures, societies emerge with different values, beliefs, and needs. So, having done the study of epistemology, we now need to do the study of how we learn about the reality. So we agree there are two types of approach to look at reality. Now, how do we learn about it? And that is the next step that we need to go. How do we learn about, how do we learn about what exists? How do I understand that existence? And how do I understand the interactions? And that is then the epistemological issues. And then again, we have two types of approach. One, the pure science one, positivist, right? That says that there are set characteristics to define about the reality is external to me. I need to learn by myself how that reality it can be modeled. I will work through experimental approaches. I will work through testing. And through testing and experimental approaches, I will come to a conclusion and to a definition of what I need. I will come to laws that explain it. Or I need to understand the reality first. And once I understood the reality, I need to select how I will try to understand the perceptions, opinions of the individuals within that particular societal environment. So again, a completely different approach. I can use experimental approach and statistics. I need to use approaches in which I try to understand perceptions, interviews, focus groups, observation. So again, completely different approaches to research. So we try to discuss understanding and knowledge. Now, what is systematic in investigation? Usually that has to do with research approaches, research strategies, research methodologies. Right? No. Because they are informed by ontological and epistemological issues. So if we don't know what the epistemological, ontological and epistemological issues we are choosing, then we may choose the wrong research approach. We may choose the wrong research strategy. You may choose the wrong methodology. So we need to actually look at research from a holistic perspective. Now, there are then two main dichotomies: the deductive research approach and the inductive research approach. The deductive research approach follows a positivist epistemology. I need to create hypotheses and I need to test them. The inductive approach follows a sense that to understand the reality, I need to interview, I need to have data first, then from that data I create theory. So that means that a deductive approach, you start with the theory, and then you create hypotheses, you collect data, you test it, you define if the hypotheses are being confirmed or rejected, and then you do a revision of theory. If I'm looking at an inductive approach, I'm looking at an approach that is actually bottom-up, meaning that I need to go into the environment, understand the environment before I make theories about it. Right? So it's a bottom-up approach. I start with data collection, I identify patterns, I try to understand the meaning of these patterns, I create propositions, I try to see where this fits in the theory, and then I make theory. So, objectivist, positivist epistemologies actually usually result in more experimental, more deductive approaches. Whereas subjective, interpretivist approach, ontologies and epistemologies result in inductive approaches. Now, that then leads to another dichotomy that we are always using, which is this quantitative versus qualitative research. Research that is done based on measurements and numbers, and research that is made on interactions, opinions, thoughts. And of course, we then have the quantitative approach that actually is based on measuring actions, from the experimental approach, in which we then use statistics, or the qualitative approach that then looks into the socially constructed nature of reality and actually comes with models, with thematic maps, with all kinds of qualitative results that are not necessarily statistics. Now, the problem is that sooner or later we come with this question, which one is better? Now, my answer is none. None is better. Actually, it all depends on the research questions that we actually choose. And the research questions then may require different types of epistemological approaches, and therefore different types of research methods, therefore different types of approaches. Now, all of this is sort of traditional research. And these dichotomies, positivism versus interactivism, deductive versus inductive, quantitative versus qualitative, technological versus user-centered focus, many others that we can start using, actually may not be appropriate. Because the world that we live in is changing so fast that, one, there is no objectivity. In the kind of research that we do related to technology, there is no objectivity at all. The technology may not exist when we actually, during our research process. And might it be that we need an approach that needs both? Might it be that we need an approach that actually is different in nature? And that is then what I started thinking some 20 years ago. We need a different approach. And I came across a guy that is a very interesting guy. He is an electric engineer and a Turing Award receiver and a Nobel Prize in economy. So obviously a very divergent thinker. Obviously somebody who thinks very deeply in very different environments, right? Obviously not me. Obviously, maybe not many of us here, right? And he came with a different, very interesting distinction. A distinction between natural and artificial systems. Natural and artificial systems. He was worried that if we are looking at artificial phenomena being things that man does rather than they exist in nature, and that we then start researching on these phenomena, that the purists of science would think this is not science. Now, you think this is a new discussion. It's not. For a long, long time, scientists say that social scientists are not scientists. Very long time. Very long time. And for a very long time, social scientists accused pure scientists to being completely biased and not actually paying any attention to what happens in the real world. So these discussions are not new. They have been happening for a long time. I had a discussion with a very famous Chinese professor, and he tells me, no. If there are no statistics, there is no science. But, sir, statistics mean nothing. If you take statistics out of a particular social group, you cannot generalize it. Because the same statistic modeling applied to a different group in a different country, for instance, may give completely different results. So just because we use mathematics, just because we use statistics, doesn't mean that we're doing science or that we're doing generalizable science. We're doing a different type of science. This then continued with him writing a phrase that I had to think for a long time. To be perfectly honest, I had to think for a long time. This seems to me not to be the real difficulty. The genuine problem is how to show how empirical propositions can be made at all about systems that, given different circumstances, might be quite other than they are now. Our problem. Our problem in information systems. This is our problem in information systems. Because the technology that we're working with now may not be the technology that we will be working tomorrow. The technology that we're starting working with may not be the technology that people are now using. Exactly the same concern. And in that sense, look, he said this in 1996, which is also curious. Because in 1996, the speed of the transformation was not so fast. But he was already worried about that then. It's very curious. And to prove this, I would like to give a very simple example. I'm asking a question. Is a bridge always a bridge? Very simple question. Is a bridge a bridge? And it's not. It's not. Because, for instance, this bridge here is a typical Chinese honor bridge, built by a rich man that wanted to show his elegance and his capacity to fund such an endeavor over a very short little water, very shallow little water that doesn't require a beautiful arch on it. So it's a statement. It's not really a bridge. Now, I would like to now discuss this one. This bridge is 2,000 years old. Was built by Roman soldiers. Was built by Roman soldiers in my father's hometown in Portugal, in the north of the country. Cars are still going over it today. Is it beautiful? Absolutely not. Is it functional? Yeah. It was built by military. They don't care about beauty. They care about passing. They built it in such a way that it's still there today. Nobody made any works on it. It's there, just there. What about this one? This is the Tower of London, the Bridge of London, a bridge that existed between the two sides of the Thames that actually was caught fire in the 18th century. And actually, what it became was a shopping mall, because the bridge was linking the two sides of the city. So people were continuously crossing around from one side to the other. Therefore, where is the best place to catch people to sell them things? In the bridge. It became a shopping mall, curiously. And then it burned because it was a shopping mall, not a bridge, because it was not prepared for any capacity. Now, this one is also Portuguese. It was the longest bridge in Europe for about 3 days. So, yes, for about 3 days. Then the Swedish and the Danes created a longer bridge by 1 kilometer. Now, the curious thing is, why do you think this bend exists? It's to protect against the flow of the river. No, it was not. Here, on this side, there is a national and European reservation that has some very important, unique birds. The European Union did not allow us to continue the bridge in this direction. Therefore, we had to cut it in that direction. So sometimes a bridge is not a bridge. In this case, the bridge is what we could do rather than what we wanted to do. And finally, what about this one? This is not even over a river. This is between two trees, two ravines, right? So a bridge is not a bridge. A bridge is what we actually want it to be, is what we make use of, is how in our culture, in our perception of things, we actually build it. Is in our culture, doesn't mean national culture. Military culture, rich man culture. It's different. So when we are actually designing things that are artificial, we need to look at the nature of the environment around us, the culture around us, not just on the technology. And that's when technology fails, is when we forget that we need to do these things. Now, I want to give you another example, and this is an interesting example. An army. An army is also an artifact, right? It's an artifact of war. Roman soldiers, they don't want to die. If they survive, they'll be given land. They will be given Roman citizenship and land. They do not want to die. They do everything to protect themselves, and if the general doesn't protect themselves, they'll kill the general. Simple as that, because they don't want to die. So they fight with big shields, very short weapons, and information in very close formation. Because shield here, weapon here, shield there. So we are protected. If we fight Hollywood style, then you can be killed by all sides. So they fought in very close formations. The Celts and the barbarians didn't fight in those. The Celts beat the Romans several times. There is a tribe of Celts in Portugal that beat the Romans twice. They took 50 years to to conquer them, a little tribe. They were very, very unorganized in their war. The war was an act of courage and an act of bravery. They wanted to fight with small shields and close combat weapons. The barbarians that everybody talks about, they came with their families. The Goths, the Visigoths, the Alans, they did not come as an army. They come as a tribe. And it's as a tribe that they defeat the Romans, because they passed the borders, and then when they set themselves inside the Roman Empire, they killed the Roman Empire. They burned the Roman Empire. They burned Rome. And also, this one is a much more interesting example. These guys here are the Mongols, right? That in the 13th century conquered basically the biggest land empire in the world, right? They fought Europeans and the Sun Chinese. The Sun Chinese had the best cavalry at the time, better than the European one. The European one was heavily fortified, but people almost could not fight inside that armor. Sun armor was articulated, absolutely excellent at that time. They have the best horses, big horses. A European war horse was huge, an incredible animal. These guys come to the world with very short, ridiculous horses, no armor, and defeat everybody. Now, you must confess that this is sort of a bit interesting, right? How these guys with ridiculously small horses, no armor, only silk shirts. They wanted the silk shirts so that they could take the arrow out without leaving the arrow inside of the body. And then they conquered the world with these ridiculous animals. Why? Both these guys moved very slow. When they moved with their food, their servants, their kilometers of units moving. These guys move very fast. They do not take any food with them. They only go on female horses. They drink the milk of the horse. If they are extremely thirsty or hungry, they bleed the horse and drink the blood. They take nothing with them. So these guys are so mobile that they can surprise the other guys in the back, in the front. They never fight big battles. They continuously surround them and defeat them. Technology. Which was the best technology? This one and this one? Yes. Which was the technology that won? That one, because of the use we do of the technology. And I think this is what is quite interesting in terms of Herbert's ideas. So when we look at the natural science, the body of knowledge is about natural objects. When we look at the artificial science, we look about man-made constructs, man-made inventions. And there is a question that is also interesting. Are we natural or are we artificial? It's an interesting question, almost religious one, right? But no, we are actually natural, but what we do is artificial. You see? And we do not live in a natural way. As soon as we started building tools, we started changing the environment around us, we started designing tools, and we started designing environments. And we stopped being natural. Okay? Now, also, so how do we do then research in a world that is not natural? How do we do research about agriculture? Is agriculture natural? Is a farm a natural thing? No, it's not. Because in nature there is multiple competing plants, there is no artificial watering of the plants. So a farm is a completely unnatural thing. So when we do research on the farm, is it pure science or artificial science? And of course, it's artificial science. So many of the research that we do in engineering, in computer science, in all kinds of manufacturing, in agriculture, is not natural science, is artificial science. We should have tools that allow us to do this. And we should have tools that allow us to actually create new designs in innovation, which was what we're talking about. So if we're doing testing of ideas that already exist, we're not doing anything new, because the progress is going in front of us, you see? So we need to have different approaches. Now, finally, just something about artifacts. So what are these artifacts that he was talking about? It's quite an interesting thing. Emperor symbols. 3 different emperor symbols. Yes, Roman Empire. I'm strong. Using armor. I am individually strong. Okay? Chinese emperor. I'm wise. I'm elegant. I'm a symbol. No strength here. Right? Only symbols of being an emperor. Typical of an empire that is expansionist and an empire that is self-centered. In an empire that is self-centered, you need to be wise. You need to be a good ruler. You need to be a symbol. In an empire that is a conquering empire, you need to be strong. So very different symbols, very different artifacts. What about this one here? Egypt. So the pharaoh is always wearing these 2 symbols. What are they? They are the symbol of the North Egypt and the South of Egypt. The North and South of Egypt fought themselves for thousands of years. And Egypt only became a great country when they actually unified. And although they unified 2,000 or 3,000 years before this symbol was used, this symbol was continuously used in order to maintain the unity between the North and the South. So the symbol of the pharaoh is, I can keep the unity. Interesting. What about the British Empire? It's a very interesting thing, isn't it? The crown over the sword. Again, an imperialistic empire based on strength, the sword. The crown is over the sword. Right? So artifacts actually have a lot to do with culture, with purpose, with structure, and the social environment where they need to be used. Now, what does design science research based on Herbert's propositions actually advocates? 1, we don't do testing of artifacts. That is done a lot in engineering, done a lot in computer science. We identify these requirements, now produce something that meets these requirements. When we finish meeting these requirements, it's done. How do you know it's useful? How do you know that what you produced according to the requirements that you predetermined yourself is useful? How do you know how it can be used in reality of practice in particular social environments? So it's more than testing. It's development and evaluation at the same time. And evaluation means that we need to know how it works and that we need to produce knowledge about how it works. Okay? So in that sense, is one step after experimental research. Because experimental research is how we did research since Newton. We test gravity, right? We create models based on gravity. If we produce software, if we produce engineering artifacts, and then we just meet the requirements that we ourselves set, how do you know these requirements are useful? How do you know that these artifacts, this software is useful? So what is proposed is that we actually look at the purpose, the usability, and the social environment of the artifacts that we're building. So it's a process in